Okay, this is lesson 6.2 in geometry, and these are working on examples 3 and 4 in the book. The check it out in number 3 for example 3 and the check it out problem for example 4 are what I will be looking at to show as examples. So the first one for check it out 3 says 3 vertices of a quadrilateral PQRS are P is -3, -2, Q is -1, 4, and S is 5, 0. Find the coordinates of vertex R. Now in example 3, they want you to make R such that the quadrilateral is a parallelogram. Well, to do that, we have to know what a parallelogram is. So we'll take a step back. What is a parallelogram? What do we know about it? Well, we know that opposite sides are congruent, opposite angles are congruent, consecutive, or angles that are next to each other, are supplemental, which means that consecutive angles add up to 180 degrees when added together. Opposite sides are parallel. That is the basics of a parallelogram. So back to our problem at hand here, we are trying to create a quadrilateral. So the first things first is we have to plot these points. So -3, -2 would be back 3, down 2 for P, left 1, up 4 for Q, and right 5 for S. Now we have to know where will R go. So here are our points and labeled here where they would be. Now to find out where R would go, we need to see the differences of them because we know opposite sides are congruent and opposite sides are parallel, which means that their slope will be the same. So we need to count that. A way to do that is just to click and count the rise over run between Q and P or between P and S. It does not matter which one you choose. Both will get you that end result. If you want to be more perfect, you can just do both just to make sure that they both align to the same point. But it'll be pretty obvious when you finally connect that last point that it's a parallelogram that you've created. So this is right 2 and down 1, 2, 3, 4, 5, 6. Okay, so that means that this one would have to be the same thing. It would have to go up 6 from S to get to R and go right 2. Or if you counted this one, it'd be 1, 2, 3, 4, 5, 6, 7, 8, and then up 2. So if I went from Q, I would go up 2 and over 8. And that's how I'd find out R. So whichever method you choose to use here, and we can use this one here. So we start from S, and we count 2 to the right, and we count 6 up. And our mystery R should be going right here, which if we connected these lines now, would create a perpendicular. Or it's not a perpendicular, it would create a parallelogram. And you could do the other way if you don't believe that it'll work. You can count up 2 for here, and then over 8. 1, 2, 3, 4, 5, 6, 7, 8. It works on both methods. You find that R is right here, and that is not over yet. You still need to put the coordinates of R, which would be 1, 2, 3, 4, 5, 6, 7 to the right. So my X coordinate is 7. And my Y coordinate is 1, 2, 3, 4, 5, 6. Okay, this is now for example 4, getting into proofs now, which some people are a little afraid of, but we'll dive in here and hopefully I can clear things up for you. So this is the check it out for problem 4 for example 4, and it's using the figure from example 4b, which I have made here below. Some of the proof from the actual 4b is similar, it's just a little different at the end. But it says use the figure in example 4b to write a 2-column proof. Given that GHJN, which is this one here, and JKLM, which is this one here, are parallelograms. So we know that they're given as parallelograms. Also, we are given that H and M are collinear, which means that they are basically a line. That's all that's saying. And also that N and K are collinear, which means that they are a line. They're not going in different directions. They're a straight line, which is good to know for making vertical angles, which is why they say that. They both share the point J, so we know that they are intersecting at J. And since H and M are on a line and K and N are on a line, we know that these angles are vertical angles, which will be useful in solving this problem. They want us to prove that angle N, which is this one, and angle K are congruent. Well, the thing I always say to do first when you're dealing with diagrams of geometry and proving is write what we know with what we're given and see what you can piece together with what you know. You can't assume that right now, just because they're both parallelograms, that they are congruent parallelograms to each other. We are not given that they are congruent, just that they are parallelograms. Okay? So, what we know about parallelograms are opposite angles are congruent, which I've shown here. Opposite angles are congruent. Opposite sides are congruent. That's what these flat lines are. The arrows mean that the opposite sides are also parallel. These opposite sides are parallel and congruent to each other. And then I did a similar with different colors so that you don't think that they are the same. We have not proven that these are equal to each other or congruent to each other yet. But in essence, they look very similar. Opposite angles are congruent. Opposite sides are congruent. Opposite sides are parallel. So that's what all of this is. That all comes from this being given right here. Okay. Now the collinear part, that has to do with the next step. Okay. That has to do with the fact that this is a line and this is a line, which will be helpful in proving. Okay. Nothing we can do with it now. We just know that they're lines that are intersecting. Okay. Now we get to the part proving that the angle N and angle K are congruent. So the first part is state what you're given. Okay, JHN and JKLM quadrilaterals are parallelograms. That is given. Okay, easy enough. So now we know all of that is true. Now, we need to also state the obvious. This angle, which you have to say the 3 points HJN and MJK, are congruent because they're vertical angles. Okay, so angle HJN is congruent to angle MJK by the reason of vertical angles theorem. The next part is angle HJN and angle JNG are supplemental angles. So HJN and JNG. HJN, which is this angle, and G and J, which is this angle, are supplemental. Because they are next to each other, they are consecutive angles, and that is one of the things we talked about with parallelograms. Consecutive angles are supplementary, which will be key in solving this. We have to state that they are supplemental angles. The reasoning: consecutive angles are congruent. Consecutive angles are supplemental, is what they should say. Okay, that's what that should say there. And also angle MJK and JKL, which are the other versions on the other parallelogram, also have to be stated that they are consecutive angles and thus are supplementary. Now, we can state the obvious because now we do have enough to solve this. We can prove that N and K are congruent, because if this is congruent to this by vertical angles, and these two angles add up to 180 degrees, if I know that these are the same, then I know that 180 minus this is going to be this angle, and 180 degrees minus the same thing over here is going to make this the same. Then we know that N and K are congruent. So you can just state that congruent supplemental angles are congruent, which is actually a theorem or a proof that will prove that for you. If you want to see an example of it, look at this. Let's say we know this angle is 40 degrees. That means we know this angle is 40 degrees because they're vertical angles. We know, because these are parallelograms and these are parallelograms, that this angle and this angle add up to 180 degrees. So x plus 40 equals 180. Well, I subtract 40 to both sides, and I get x equals 140. I do the same thing over here, and I get the same thing, x equals 140. That is the proof that that theorem is talking about. So just to recap again, we said that they are parallelograms. We said that angle HJN is congruent to angle MJK by vertical angle theorem. Then we stated that the consecutive angles were supplementary, which is part of the given for parallelograms. And then we said, well, we've got enough now to say if a congruent angle is supplementary to another angle, then they are congruent to each other.